Simplifying fractions. All right, so the key to this is understand the idea of one. A number divided by itself is one. It doesn't really, people say, oh, they go away. They don't really go away, they reduce to one. So basically, what we need to do is find and ask ourselves, is there anything that's the same at the top and the bottom through multiplication in each fraction? So there's lots of ways to find those numbers, and that's where most people struggle. What I recommend is asking ourselves is we need to factor and break the numbers, the numerators and denominators, up into two numbers being multiplied. And picking those numbers can really be a hassle. So what I recommend for people is I'm only looking to see if each number has a factor of 2, 3, 5, 10, kind of easier numbers, and just going from there. So the first one here, I can look at and both of those multiply by 2, right? So 1 times 2 and 2 times 2 is the same as 4. So now see that I have this 2 times 2, there's a giant 1 that reduces, right, to a 1, and 1 times anything is itself. So what we're left with is just the half. So I'm not really crossing it out from the perspective that it's going away. I'm doing it from the idea that it's equaling 1. 8 over 4. So same thing here. Okay, when I ask myself, is there anything I can do? I'm going to break it up into twos. I can take a 4 out. I'm just going to keep it simple. So I broke it up into twos. That's a 1. But then I go, you know what? I can do this 4 and 2 again, and there's another 1, right? So you can see I could have took out a 4 from the beginning. But also you look at it here, well, that's the same as 2. And we know 8 divided by 4 is 2. This was a test question. There's no reason to do all of this. I just wanted to show you can go straight from here to the end. All right, 6 over 18. So I ask myself, I'm going to break this up into twos. So 2 times 6 and 2 times 9. They're my twos. That equals 1. But then I look at my 3 and my 9. I go, you know what? I can do a 3 for this, right? 3 is the same as 1 times 3, and 9 is the same as 3 times 3. There's another 1, and so it's just 1/3. Okay, people are tempted to put 3. We're going to do 18 divided by 6, and it's not the same thing. All right, so I got negative 12 over 18. And the first thing I like to do is deal with that negative. So no matter what I have, I just put a negative 1 out front. And then I look for a 2. And I go, oh, yeah, 12 is 6 and 2, and 18 is 9 and 2. So there's a 1 right there. And then I go, okay, now I'm going to look for another 2 or a 3. I can take a 3 out of these. So that's why I get my 2 times 3. My 3 times 3, there's another 1. All right, got that negative still floating around right there. And there's my final answer. Negative 20 over negative 25. So I'm going to pull the negative out front, make that a negative 1. Then I'm going to say, okay, what can I break these up into? I can't break them up into 2 or 3 or 4, but they each have a 5, right? So the negative 1s actually reduce, and the 5 reduces, and I'm left with 4 over 5. So same thing, I got one negative in the top. I'm just going to go ahead and pull that out. And 24 is the same as 2 times 12, and 40 is the same as 2 times 20. And remember, if you can take out bigger numbers besides 2, 3, and all these other ones, you can do that. I'm just picking smaller numbers to work with and doing it multiple times. So those equal 1. Oh, there's another 2 because 12 and 20 each have a 2. Oh, what do you know? 6 and 10 also have a 2, right? And then finally, I'm left with this. Nothing else reduces. And you can see here, oh, yeah, I could have took an 8 out in the beginning, which is the same as 2 times 2 times 2. And it's completely fine if you take an 8 out in the beginning and just do everything in one step. 42 over 30. So I'm going to go ahead and break it up into twos. Remember, I'm trying to do 2s, 3s, and 5s. So those reduce, right? And then I say I got 21 and 15. There's a 3 in there. They each, all right, have a factor of 3. There's another 1. And then I get 7 over 5. Next one. So here I got a big number, okay? So this is where, this can be really a hassle if I'm taking it 1, 2 at a time, right? But the big thing here is they both end in a 0, so I'm going to take a 10 out first. That just makes my life a lot easier. So if I ever can take a 10 out, I'm going to take a 10 out, or 100 or 1,000. I got that negative, right? So here I can tell, hey, both of these are even, so I can take a 2 out. That's why I like taking out 2s. There's a 1. Got another 2 in there. 56 and 44 are both even, so there's another 1 of 2s. Right? Oh, another 2. Right? And you can see 14 over 11, there's nothing else that comes out. I got to multiply by that negative 1. 20 over 10, okay, and versus 10 over 20. So people are going to put these as the same answer. So what I get here is 2 times 10 and 2 times 5. And down here, 2 times 5 and 2 times 10. Look at, they each have a 2 that reduces out, right? However, look at the 10, the bigger numbers on top, and here the bigger numbers on the bottom in the denominator. That's not going to change. So now I end up with this, and everything's kind of looking the same, right? 10 is got a 2 and got a 5 in it. But now look what I have as answers. 2 over 1 and 1 over 2. Those are not the same thing. That equals 2, right? Sorry. That equals 2, and then this one equals a half. They're not the same answer.